now I'm going to go over a more complicated circuit, just with different resistances within the resistors. So here I have R1, which is 2 ohms. Here now I have a resistor R2, which is 4 ohms. And then I have another resistor R3, which is 2 ohms. And I'm picking numbers so that the math is a little bit cleaner. And R4 is 4.5 ohms. And we have 12 volts at the power supply. And so, just like I did before, I'm going to combine resistors just through the diagrams themselves, then go back and work through the calculations. So the first step would be to combine R2 and 3. So here's R1, here's R2, 3, here is R4. And the next step will be to combine 1 with 2 and 3, and these two are in parallel with each other. So this is R1, 2, 3, and this is over to R4. And then finally I will combine these two that are in series. So this is the R equivalent for the circuit. So now that I've marched my way down here and made it simpler and simpler and simpler until I end up with a simple circuit, I'm going to go back up and try to work my way as I go up, filling in all the values, whether it be current or whether it be voltage drop for all of these. So my first step would be to combine these two, R2 and 3, so I can figure out what this value is here. So combining R2 and R3 is pretty straightforward. R2 plus R3 is then just going to be equal to 4 plus 2, which is equal to 6 ohms. So this is equal to 6 ohms. Now, this is a little more difficult. I'm going to combine R1 and R2, 3, so these are in parallel. So now my R1, 2, 3 is equal to 1 over R1 plus 1 over R2, 3, which is equal to 1 over R1 is 2 ohms plus 1 over R2, 3 now is 6 ohms. So a half plus a 6. This is going to equal 4 over 6, so this is 2/3. So I have 1 over R1, 2, 3 is equal to 2 over 3, or now I have to flip these over. So R1, 2, 3 is then equal to 3 over 2, or 1.5 ohms. So this is 1.5 ohms. And now my R equivalent, I can just do this right here. I have my R equivalent is 1.5 plus 4.5. So that 1.5 plus 4.5 is just equal to my 6 ohms. So this is 6 ohms. So now I've got all of my resistors combined to come up with this simple circuit. Now I'm going to pick it apart and work my way back through. With this, I will first figure out maybe what the current is across the source. So the current across the source is the voltage at the source over R equivalent. This is pretty straightforward. 12 volts over 6 ohms, or we have 2 amps. So I'm going to label that in here. 2 amps. This is 2 amps. I have 2 amps up here. I have 2 amps here. And so then it'll divide here, it'll divide here. So I've started. Now my next step is I have all of the known values right here. So I have what my voltages are. I have 12 volts, 0 volts, 0 volts. Here I have 12 volts, 0 volts, 12 volts, and I don't know what the voltage is in here. What is the voltage drop across R1, 2, 3, or what is the voltage drop across R4? So I will find the voltage drop across 1, 2, and 3, which is I across 1, 2, and 3 multiplied by R 1, 2, 3. And my I is this 2 amps multiplied by my R, which is my 1.5 ohms. And this is equal to my 3, what am I doing, voltage? 3 volts. 3 volts. 3 volts. So that's a 3 volt drop. 3 volt drop. I have 12 minus 3 is 9 volts. 9 volts here. So I will go up here. I have 12 volts, 12 volts, 12 volts, as these wires are all connected. It drops across these. These are both end up at 9 volts. And this drops again as these come back together to 0 volts. So now I know what the current is. I need to know how the current splits. And these resistors aren't equal, so the current through 1 is not equal to the current through R2, 3. But I do know that they have to sum up to 2 amps. So I across 1 is going to be equal to the voltage across 1 over R1. So my voltage isn't 12, isn't 9, it's actually 3 volts. So 3 volts is the drop or the difference over my resistance, which is 2 ohms. So this ends up being 1.5 amps. So I have 1.5 amps that will be flowing through here. I better have a half amp flowing through 2, 3, and I will check that. I 2, 3 is then equal to the voltage drop across 2, 3 over R 2, 3. And this is going to end up being, let's see here, the voltage drop again is still 3 over my resistance, which is now a total of 6. So this is a half of an amp, or 0.5 amps. So this is 0.5 amps that is flowing through here, which is expected. This is a lot more resistance on this branch of the circuit as compared to this branch of the circuit, so it won't have as much current flowing through there. So now I have, let's see, what do I have here? If I go up here, I know that the current flowing through here is 1.5 amps. I know that the current flowing through this branch is 0.5 amps. I know that the voltage here, all across here, is 12 volts, 12 volts. I know that the voltage here is 0 volts. I know that the voltage on the other side of this is 9 volts, so that's 9 volts there, and it's 9 volts all the way over here, but I don't know what the voltage drop is across here. So now I will find the voltage drop across 2 is I2, R2. So this I is 0.5 amps multiplied now by my R, which is 4. This is going to be 2 volts. 2 volts brings me from 12 volts down to 10 volts. And if I do it again, I have the current of a half current multiplied by 2, that would be 1, that would bring me back down to 9. So that checks out. So now the last thing I need to do is I need to figure out the power for each of these. So first it's the power at the source is equal to the I at the source, which is 2 amps multiplied by 12 volts, a total of 24 watts, or 24 joules per second is delivered or supplied by that voltage source, which could be a battery or it could be a motor or something like that. So now I want to figure out what the power is in R1, R2, R3, and R4. And then that could relate, let's say, to the brightness of bulbs, if these are all bulbs. So let's see, power at 1 is equal to the I at 1, which is 1.5 amps, multiplied by the voltage drop, which is 3 volts. So this is going to end up equaling my 4.5 watts. P at 2. I don't know, let's do this a little bit differently. if we did IV, if we placed V with IR, we end up with my I squared R, which is then my 0.5 squared multiplied by my R, which is 4. 0.5 squared is 0.25. 0.25 times 4, that just ends up equaling 1 watt. P3, we'll do this just for variety, V squared over R. That's instead of IV, I'm replacing I with V over R, so that's V squared over R. My voltage drop here is now 1. 1 squared is 1 over my resistance, which is 2. This is 0.5 watts. So if I look at right here, I have 5, I have 6. Oh boy, I need to get, what is that, 8 watts? Is that right? No, 16. 16 watts is what I have left. So P4 is equal to, let's just do IV. So 4, it ends up taking all of the amps flow through 4, all of the current flows through 4, multiplied by my 4.5. Something's gone wrong here. So this ends up being my 9 watts. Did I goof up the math here? Let's see here. My P1 should be 4.5. My P2 should be 1. My P3 should be 0.5. My P4, IV. Yeah, sorry, I put IR. IV down here is 9 volts. This makes this, 18 watts and not 9 watts. So therefore, let's see if this math works out. I guess my math from before didn't work out. So let's see, I have 18, 19, this ends up being 23 and a half, 24, it checks out. All right.